Hi folks, today we're going to teach you how to do the 20s, which is balancing equations. It starts off with a few questions at the very beginning. In a chemical reaction, the stuff on the left side of an arrow is called reactants. This should be at the very top of your sheet if you can't figure out what we're talking about. And the stuff on the right-hand side would be products, and the arrow itself would be considered the word yields or produces. So that's at the very top of your sheet. Pause this if you need to write those items in. Number 2, it says in a balanced equation, the big numbers like the 3 and 3H2O, those would be called, pause it if you need to, but the answer is coefficients. And the small numbers, like this 2 in H2O, those would be called subscripts. Both of those have infinite number of sig figs. These type of reactions right here, we're going to use them on this worksheet and the next worksheet, but that is the last time that you will have to tell us what kind of reaction it actually is. We're just giving you exposure to this, so when you go off to college, you're not completely dumbfounded when they say some of these words. So in this very first one right here, I'm going to move this off to the side. In this very first problem, what you do is you write the elements that are in the reaction right underneath the arrow. So in this case, we have sodium, hydrogen, and oxygen. We count up the number of each element. So in here we have 1 sodium on this side, and we have 1 sodium on that side. In this problem, we have 2 hydrogens on the left side, and we have 3 hydrogens on the right side. And on the left side, we have 1 oxygen, and on the right side, we have 1 oxygen. Please pause the video at this point in time if you don't understand where those numbers come from. Really analyze how did I count those in the balanced equation. So if you don't understand, please pause it at this point in time. So I'm going to assume that you understand where the numbers came from. So in this problem, I have 3 hydrogens on this side, and I have 2 hydrogens on this side. That isn't very helpful. Let's see, what else can we work on here? We have 1 oxygen on each side. Well, what if we did this? If we have a 1 in each of these blanks right now, we end up having 1 oxygen, or excuse me, 1 hydrogen. Let me start all over again. We end up having 3 hydrogens right on this side. So that's it. If we have 1 H2, and we have the H from here, that equals 3 hydrogens on this side. So 1 gives us 3 hydrogens, but we want 2 hydrogens. If we put a 0 in this blank, we would have 0 H2, and we would have this 1 hydrogen, and that would give us 1 hydrogen on this side. If there was only a number that was between 1 and 0 that we could pick from to get the proper number of hydrogens, and the answer is 0.5 or 1/2. So how we solve this problem is we simply put a 0.5 in here. That will give us 1 H from there, 1 H from there, and give us a total of 2 H's on this side. That's called the 0.5 method. The problem, though, is we have to multiply the whole thing by 2 to get rid of that 0.5. So this would turn into a 2. This would turn into a 2. This would turn into a 2. And 0.5 times 2 is 1. So that is the correct balanced equation. We will use this 0.5 method a lot today and tomorrow. Pause it, take a look at it, rewind it if you need to, and we are off to the next problem. So again, in this problem, what I will do initially is write the elements right underneath the arrow. So I have carbon, I have hydrogen, and I have oxygen. I'll count up the number I have on each side. I have 1 carbon on the left side, and I have 1 carbon on the right side. I have 4 hydrogens on the left, and I have 2 hydrogens on the right. I have 3 oxygens on the left, and I have 3 oxygens on the right. Pause the video, take a look, see where I got those numbers from, understand it. Don't go on until you can figure out where those numbers came from. Well, let's assume that you did that and you're all set to go. So, hydrogens. I would immediately look at this and say I have 4 hydrogens here. I want 4 hydrogens on this side. So I put a 2 right there. I no longer have 2 hydrogens. I have 4 hydrogens on this side. And my oxygen number went up to 4 as well. So I got everything balanced now besides the oxygens. Right now there's 1s in all of these blanks. So if I have 1 O2 right here, 1 O2, I have O and O, and I have another oxygen from right there, so I have another O. I have 3 O's, 1, 2, 3. That's if I have a 1 in this blank. If I put a 2 in this blank, I would have O, 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 and a third O from right there. Now I have 5 oxygens. So right here I have 3, here I have 5, but I need this number to be a 4. If there was only a number between 3 and 5, what number could be between 3 and 5? And that would be 4. How do I get to 4? That's an interesting question. So if I put a 1 in this blank, it's too little. If I put a 2 in this blank, it's too much. So let's put a 1.5 in this blank. 1.5 will get us 1 oxygen with an O2, another half of an O2. We have this O right here, which gives us a total of 4 oxygens on this side. Again, we have to multiply the whole thing by 2 to get rid of that 0.5. So we end up with a 2 there, we end up with a 3 there, we end up with a 2 there, and we end up with a 4 there. And now it is our balanced equation. Take a look at that, and then move on to the next one. Same thing as before, I'll write down the elements. I have Ca, calcium, I have carbon, I have hydrogen, and I have oxygen. I'm going to count up the number of each. I have 1 calcium on the left side, and I have 1 calcium on the right side. And I have 2 carbons on the left, and I have 2 carbons on the right. And I have 2 hydrogens on the left, and I have 2 hydrogens on the right. And I have 1 oxygen on the left, and I have 1 oxygen on the right. Darn, that's balanced. Done. On to the next problem. This time, see if you can write out the elements underneath the arrow before you progress this video any further. Got carbon, we got hydrogen, we have oxygen. Try to figure out the numbers before you progress this any further. 2 carbons, 1 carbon, 2 hydrogens, 2 hydrogens, 2 O's, 3 O's. So right now I have 1s in all these blanks. So with that, with 1 O, I have an oxygen and an oxygen. It's 2 O's. If I put a 2 in this blank, I have oxygen, 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 and that's 4 O's. So 1 O2 is too many, 2 O2s is too much, so I must need a number in between 1 and 2, and that would be 1.5. Now I have 3 oxygens. I multiply the whole thing by 2, 2, 3, 2, 2, and it is balanced. Try the next problem on your own before you watch the video on it. Alright, in this problem I have nitrogen and I have iodine. On the left-hand side, I have 1 nitrogen. On the right-hand side, I have 2. On the left-hand side, I have 3 iodines, and I have 2 on the right-hand side. So, simplest thing for me would be to put a 2 here, That's going to bring my nitrogen number up to 2 on each side. But it's going to bring my iodine number up to 6. So to counter that, I put a 3 over here, and that brings this up to 6, and I am balanced. As before, please try the problems first before you progress the video any further. I have Na, I have carbon, I have oxygen, I have hydrogen, I have chlorine. On the left side, I have 2 sodiums. On the right side, I have 1 sodium. On the left side, I have 1 carbon. On the right side, I have 1 carbon. On the left side, I have 3 oxygens. On the right side, I have 3 oxygens. On the left side, I have 1 hydrogen. On the right side, I have 2 hydrogens. On the left side, I have 1 chlorine. On the right side, I have 1 chlorine. So looking at all of my choices, I'm probably going to start with the sodium. So I'll put a 2 here. That'll bring my sodium count up to 2, but it'll also bring my chloride count up to 2. I'll go over on the left side. I'll put a 2 here to get my chloride count up to 2. And if I look at it, it changes my hydrogens as well, and everything is balanced. So sometimes the big ones are not very hard to solve. And the last one that we have for the day. Again, try to solve this first and then watch how it is solved. I have barium, I have nitrogen, I have oxygen, I have potassium, I have chromium. Go ahead and count the numbers of each of those. I have 1 barium on the left and 1 on the right. I have 2 nitrogens on the left. I have 1 on the right. If you don't understand where the 2 came from, stop the video, really give it a good look, and see if you can figure it out. I have 6 oxygens there, and I have 4 oxygens there, so I have 10 on the left side. I have 4 there, and I have 3 there, so I have 7 on the right side. I have 2 potassiums on the left side. I have 1 potassium on the right. I have 1 chromium on the left, and I have 1 chromium on the right. So I'm going to look at all of that. I got my bariums balanced. I'm probably going to jump right in and try to balance the nitrogens or the potassiums. Either way, I'm going to put a 2 here. That's going to bring up my nitrogen count to 2. It's going to bring my potassium count up to 2. It's going to give me 6 oxygens here, and I have 4 oxygens here. So that's 10 oxygens on this side, and voila, I am done. That's balancing equations. Come on in if you need any extra help with it. The 0.5 method is a great way of solving many of these problems.